Hello, hello, and welcome to the lecture session number 2. So, students, today we will discuss on the second part of the fuel cell. In the previous class, means lecture number 1, we will discuss about the basic things of the fuel cell. That is, definition of fuel cell, its working principle, its history, its timeline, its procedure, and its construction. Today, we will go discuss today we will discuss on the different types of the fuel cells. So let's start with the today's session. So students, there are five types of fuel cell. One is alkaline fuel cell or AFC. Number 2 is proton exchange membrane fuel cell or PEMFC. Number 3 is phosphoric acid fuel cell or PAFC. Number 4th one is molten carbonate fuel cell or MCFC. And the last one is solid oxide fuel cell or SOFC. So students, these are the basic 5 types of the fuel cell. So let's elaborate it. Let's elaborate this fuel cell. Start with the AFC. AFC means alkaline fuel cell. This is the oldest design of fuel cell. The AFC or alkaline fuel cell is the oldest design fuel cell, which is introduced in the early of 1960s. This fuel cell introduced in the early of 1960s. It requires pure hydrogen and oxygen, or it operates on compressed hydrogen and oxygen. They generally use a solution of aqueous alkaline solution like potassium hydroxide solution or KOH as an electrolyte. It produces electricity consumption is rather expensive. The efficiency of this fuel cell. The efficiency of this fuel cell or alkyl fuel cell is about 70%. And the operating temperature of this fuel cell is lie in between 150 degrees Celsius to 200 degrees Celsius. The cell output range from 300 watt to 500 kilowatt. The cell output range. The alkaline fuel cell or AFC output ranges from 300 watt to 5 kilowatt. These cells were used in Apollo spacecraft to provide both electricity and drinking water. For this purpose they require pure hydrogen and the oxygen, and they use platinum as their electrocatalyst, which are expensive. And like any container filled with liquid, they can leak. So there is some safety required. The leak-proof container will be required for this, no leakage. Otherwise, it is okay. It requires pure hydrogen and oxygen as a fuel, potassium hydroxide or KOH as an alkaline solution, or electrolyte, and platinum as a catalyst. The efficiency of this fuel cell is near to 70%. The operating temperature is in between 150 degrees Celsius to 200 degrees Celsius, and the cell output ranges from 300 watt to 5 kilowatt. So students, these are the basic things of the AFC, and here is a diagram of the AFC. Next is PEMFC, or proton exchange membrane fuel cell. PEMFC. Here polymer is used as an electrolyte in a form of thin permeable sheet. The efficiency is 40% to 50%. Operating temperature is about 80 degrees Celsius. The cell output is 50 to 250 kilowatt. Flexible electrolyte will not leak or crack. Cell operate at a low temperature to make them suitable for home and car. Platinum as catalyst. Means this fuel cell working with a polymer electrolyte in the form of a thin permeable sheet. So thin permeable sheet is used. Permeable sheet of polymer is used as an electrolyte. Efficiency is 40 to 50%. The operating temperature of PEMFC, or proton exchange membrane fuel cell is 80 degrees Celsius. Generally, the cell output range from 50 kilowatt to 250 kilowatt. Output range is 50 kilowatt to 250 kilowatt. Flexible solid and flexible electrolyte will not leak or crack. These cells operate at a low enough temperature to make them suitable for home and car, but the fuel must be purified. So hydrogen is much purified hydrogen is used for this proton exchange membrane, and platinum catalyst is used on both sides of the membrane. That's why it is raising the costing. So students, PEMFC, or proton exchange membrane has polymer electrolyte, platinum as a catalyst. Efficiency 40 to 50%, keeps 40 to 50%, operating temperature 80 degrees Celsius, cells output 50 to 250 degrees kilowatt. So after the PEMFC, the next one is PAFC. PAFC means phosphoric acid fuel cell or PAFC. For the PAFC, phosphoric acid is used. Phosphoric acid is used as as an electrolyte. Its efficiency ranges from 40 to 80%. The efficiency ranges of phosphoric acid fuel cell is 40 to 80%, and operating temperature is between 150 degrees Celsius to 200 degrees Celsius. Existing phosphoric acid cells have outputs up to 200 kilowatt and 11 megawatt unit has been tested. This PAFC or phosphoric acid fuel cell output power is up to 200 kilowatt, and it has been tested 11 megawatt. This 11 megawatt is the only for testing purpose. It will be shown and it is successful. In natural, the power range is 200 kilowatt. The PAFCs or phosphoric acid fuel cells tolerate a carbon monoxide concentration. Phosphoric acid fuel cell tolerate a carbon monoxide concentration of about 1.5%, which broadens the choice of fuel they can use. If gasoline is used, the sulfur must be removed. So that's why it's a sulfur-free gasoline can use as a fuel of this fuel cell. The electrolyte is very corrosive. Here, platinum electrode is used. Its internal part must be able to withstand the corrosive acid. This electrode, that's why it's acid. So this was why its electrode is very corrosive. Here, platinum is used as a catalyst. This fuel cell commonly used in the commercial car. So here, students, here is the picture of the PAFC or phosphoric acid fuel cell. Then next one is MCFC, means molten carbonate fuel cell. This molten carbonate fuel cell use high temperature compound of salt. It uses high temperature components of salt or like sodium and magnesium, it's carbonate. So basically it is used the alkaline molten alkaline carbonate like sodium bicarbonate and electrolyte. So after this electrolyte, the efficiency ranges from 50 to 60% and operating temperature is about 650 degree Celsius. The unit, the output up to 2 megawatt has been constructed. 2 megawatt has been constructed, but design exists for the unit of 100 megawatt. That's why we have produced 100 megawatt. The high temperature limit damages from the carbon monoxide poisoning of cell. And waste heat can be recycled to make additional electricity. The high temperature limits damage from carbon monoxide poisoning of the cell, and waste heat can be recycled to make additional electricity. Their nickel electrocatalysts are expensive compared to the platinum used in other cells, but the high temperature also limits the material and shape use of molten carbonate fuel cells. They would probably be too hot for home uses. Also, carbonate ion from the electrolyte are used up in a reaction, making it necessary to inject carbon dioxide to the compensate. And this is also used in the commercial for the purpose. So, students, in short, MCFC is a molten carbonate fuel cell where sodium bicarbonate is used as an electrolyte, where the efficiency is near to 55%. Operating temperature is about 650 degrees Celsius. It is normally produced 2 megawatt, but it is designed up to 100 megawatt. This is basically used for the high power generation, and this is normally used for the commercial. So after knowing the MCFC, and this is the picture of the MCFC. Next is SOFC, or solid oxide fuel cell. So solid oxide fuel cell, which is use a hand ceramic component of metal. The solid oxide fuel cell use a hard ceramic compound of metal like calcium or zirconium. As and electrolyte. So the efficiency of this, the efficiency of this fuel cell is about to 60%, and operating temperature is about to 100 degree Celsius. So students, this fuel cell is a very high operating temperature. This fuel cell is designed up to 100 kilowatt. At such high temperature, just because of its operating temperature is 100,000 degrees Celsius, it is so high temperature. A former is not required to extract hydrogen from the food, and waste heat can be recycled to make additional electricity. However, the high temperature limits application of SFC units, and they tend to be rather large. While solid electrolytes cannot leak, they can crack. So students, this is the diagram of the solid oxide fuel cell, or SOFC. So here, this is a mostly commercially used fuel cell. It has high operating life. The operating temperature is 1000 degree Celsius. The efficiency of this fuel cell is near to 60%. It produces water in the form of steam just because of its operating temperature is so high. So that's why it easily transported through steam turbine to produce more electricity. This is the plus point of this fuel cell. Here as an electrolyzed Z YSZ YSZ is used. YSJ stands for Yatria Stabilized Zirconia. This is YSZ is used as an electrolyte. Unwanted number of reaction taking place inside the cell due one the high temperature. So in short, it is a high temperature operating fuel cell. It produces it for this fuel cell YSJ, or reactor stabilized zirconia is used as an electrolyte, and just because of its high operating temperature, it produces steam water. Steam water. Steam water. So, students, this is the basics SOFC. Now comes to the comparison. Comparison is PEMFC, AFC, PAFC, MCFC and SOFC. So this is the basic comparison of PEMFC or proton exchange membrane fuel cell, AFC alkyl fuel cell, PAFC phosphoric acid fuel cell, MCFC molten carbonate fuel cell, and SOFC solid oxide fuel cell. As an electrolyte for PEMC is solid organic polymer. Aqueous solution of potassium hydroxide is used for the AFC. Liquid phosphoric acid is used for PAFC. Liquid solution of lithium sodium and or potassium carbonate for the MCFC, and YSZ or yttrium stabilized zirconia is used for the SOFC. Temperature ranges. From these comparison we can learn that the lowest operating temperature is required for the PEMFC or proton exchange membrane fuel cell, and the higher temperature is required for the SOFC. It's near to 1000 degrees Celsius. From the comparison table, you can find out the lowest output is for AFC, where the output is 300 watt to 5 to 10 kilowatts, and higher is SFC solid oxide fuel cell. In efficiency, the highest efficiency of the fuel cell is 60%. That is for the alkaline fuel cell. And shows there are some application there of these 5 fuel cells. After the comparison and knowing the types of the fuel cell, let's consider application of the fuel cell. Fuel cell can be used as power source in a remote area. It can be used to provide of power supplies. It can be applicable in both hydraulic, heavy and electric vehicle. Waste water treatment plant and uphill. The wastewater treatment plants and landfilling, buses, cars, planes, boats, forklifts. There the application area. There are the application area of the fuel cell. After the knowing the application of fuel cell, let's come to the benefits. Water is the only discharge just because of pure hydrogen. Pure hydrogen is used, so water is the only discharge. Higher efficiency than the conventional engines. Excellent part load characteristics. Zero emission. Long operating period between the failure. Negligible noise pollution. No returning parts in the main hardware component. So these are the benefits of the fuel cell. In this universe, everything has their benefits and they have also their some limitation. So what are the limitations of the fuel cell? Carbon dioxide discharge with the methanol we form little more efficiency than the other alternatives. Technology currently expensive. Many design issues still in progress. Pure hydrogen is difficult to handle. So these are the limitation of this fuel. So students, in today's lecture session, second part of the fuel cell, we learn different types of the fuel cell, their diagram, and the application of the fuel cell, advantages and disadvantages of the fuel cell. And still this, now stay home and stay safe. Take care. So students, thank you.